Welcome back to another day in the life of geometry. We are going to continue our notes today with 4-3, which we're going to start looking at congruence a little bit differently. We're going to start looking at, okay, I know that these two shapes are congruent, right? Because all three of their sides are the same, or all three of their angles are the same, or both, right? Angles and the sides have to be the same, right? Same shape, same size to prove congruence. But you don't necessarily need to know all three sides, and you don't necessarily need to know all three angles in order to say that two shapes are congruent. So that's what we're going to look at today. And specifically, we're going to be able to prove that two triangles are congruent using either side angle side, so that's the SAS, or side side side, which is the SSS. And then we're going to talk about this CPCTC, and we're going to talk about that quite a bit. Okay, so don't stress about that. No new vocabulary today, but we do have three. They're not theorems or postulates, they're criterion or conditions. And so we're going to look at those three. So go ahead and jump to the back of your notes, and let's talk about these three. All right, so here we are on the last page in our packet, the theorems and postulates page, and we're going to look at these three terms right here. So first one being side angle side congruence condition. And so what this means is if I have two triangles, so we're going to draw two triangles here. The second one's not so great, but that's okay. And I'm going to label it A, B, C, and D, E, F. Okay, so what side angle side congruence says is that if I know that two sides are the same, so I'm going to say that AB, so side AB and side DE are the same. And the reason I know that they're the same is because of those tick marks, right? And then I'm going to say that side BC and EF are the same. And I know that because of the two tick marks. So if I know two sides are the same, and I know that the angle between them is the same, so angle B is equal to E, right? So these two are the same angle measure. AB and DE are the same length, and BC and EF are the same length. Then that is enough information to show that these two triangles are congruent. So now I can say that triangle ABC is congruent to triangle DEF by side angle side condition. Okay, I guess we don't really need the period. So all that means is I know two sides are the same. Do I know what these side lengths are? No. And it doesn't matter because I have the tick marks. And so that's enough information for me to say that they are the same. I don't need to know what the actual length is, okay? Same thing with the angle. All I know is that angle B and angle E are the same. I don't have to know actually what the angle measure is. So if I know two sides and the angle between them, the angle has to be between the sides, okay? So like this angle out here is not between the two sides. So it has to be those two sides and then the angle that meets those two sides. And that would be enough information to show that the triangles are congruent by side angle side. The other condition that we're going to look at is side side side. And so all this one is the same idea. So if I have two triangles, so I'm going to draw two triangles, and I'm going to call this one ABC again, DEF. Okay, and so side 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 condition just tells me if I know that AB and DE are equal, and I know that BC and EF are equal, and I know that AC and DF are equal. So if I know all three sides, right, then I can say that these two triangles are congruent. They are the same shape and the same size. So I can say that triangle ABC is congruent to triangle DEF. And in this case, they're congruent by side, side, side. Okay, so they're the same shape and the same size because I know that the corresponding sides are equal. The last thing that we're going to talk about here is CPCTC, and I know there's a lot of letters going on. What it means is corresponding parts of congruent triangles are congruent. It's also a lot of words, right? So let's break it down into smaller pieces so that we can really understand what this means. Okay, so the first part says corresponding parts of congruent triangles. So it says if two triangles are congruent. So let's go ahead and draw two more triangles. Right, every time I draw one, it gets better. Let's have some fun with the names. Let's let this triangle be PIG, and this triangle can be COW. Okay. So congruent triangles. They are the same shape and they are the same size. Okay. So if these triangles are congruent, so I'm going to say if triangle PIG is congruent to triangle COW, then all of their corresponding parts are congruent, meaning I can say that side PI is congruent to side CO, right? They're corresponding parts, right? This side and this side are corresponding so that they are congruent. I can also say that angle G is congruent to angle W, right? They are corresponding parts. They are in the same position. And I can do that for all three angles, and I can do that for all three sides, right? So what this means is corresponding parts, parts in the same position within congruent triangles are congruent. So if I have two triangles that are the same, right, the angles that are in this, the two angles that are in the same position are the same, and the two sides that are in the same position are the same, right? And I can keep going here. I can say that angle P is congruent to angle C, right? I can say that PG is congruent to CW, and so on and so forth. And I can keep going, but I'm not going to. Okay. So we just use this to say, hey, if the triangles are congruent, then I know that every single corresponding part is also congruent. So that's it for our terms today. So we're going to go back to the start of 4.3 so that we can actually take some notes, and we're actually going to review some stuff that we did in 4.2 and then get into the 4.3 section. Okay, so let's start with example 1 here. In example 1 and the chart is just reviewing our mapping that we did from last lesson. If you don't remember, or if you haven't watched the video, make sure you go back and watch the 4-2 video where we worked on transforming shapes onto each other. But this says, what rigid motion or composition of rigid motions shows that triangle RST maps onto triangle XYZ? So how can I get this triangle to line up perfectly with this triangle? And there's a lot of different ways that you can do this, right? Just like we talked about in 4.2, right? The ways that I did it on the video aren't necessarily the only ways to do it. But kind of the first way that I see is that, hey, I want this angle that I know to be pointing down. So I'm going to need to reflect this triangle So I'm going to reflect over point S. And what that's going to give me, more or less, is that, right? And this is R, this is T. So more or less, it's going to give me that. Okay, now I want it to line up over here on this triangle, so then I can also do, and remember when we do our composition, the thing on the right is the one that we do first, right? So this is what I would do first, is I would reflect over C, and then I would translate it. Now, I don't know how many units or anything I would translate it. I just know that I would translate it in this direction. So I'm not going to put the little like triangle bracket things because I don't have units to describe the transformation, but I do know that I'm going to reflect over point S and I'm going to translate. Okay, is that the only way to do it? No, not at all. There's a lot of ways to do it, but that's just one of them. Okay. So I want you guys right now to go ahead, pause the video, and I want you to try this one. It says, what rigid motion or composition of rigid motions shows that triangle UVW maps onto XYZ? So same thing. What composition of rigid motions is going to take me from this first triangle to the second triangle? So go ahead and hit pause, try it, and then when you're ready, hit play. Okay, so hopefully we tried this. I'm feeling okay about it. Again, lots of different ways to do this. Lots of different ways. But what I see is that, again, the angle that I know, I want it to be pointing to the left. So I'm going to reflect this over point W, which gives me something like this. Right? And then all I have to do is just slide it to the right. So then I can do a composition and then just translate it to the right. I don't know how many units because it's not on a coordinate plane, but I just know that I will have to translate it to the right. Now, again, is that the only way to do it? No, that's just one way. If you got another way, that's great. I just want to remind you also that reflection is always a capital R and rotation is always a lowercase r. So just make sure that we are being really careful on that, okay? All right, let's look at another example where we practice some of this mapping. Okay, so example 2 says, Allie cuts 2 triangles from a regular piece of metal along the dashed line to make earrings. How can Allie show that the earrings are the same size and shape? Okay, so see how she did cut this along the line BD? I'm going to go ahead and draw these two separately. So there's one, right? And then I'm just going to draw this one up above like this. So all I've done is I've separated it. So this is B, this is C, this is D, and this is A. Okay, so I just took this rectangle and just kind of split it a little bit. Now, we have to also think about if it's a rectangle, then I know that this side and this side are the same, right? So I'm going to put in those tick marks. I know that those two sides are the same, right? Because it's a rectangle. Because it's a rectangle, I also know that BC and AD are the same. So I can put that in. So that's good. Also in a rectangle, I know that angles are 90 degrees. So I know that this is 90 degrees. So just drawing in things I know. And then also, do you see how line BD cuts this in half? Is line BD the same in both triangles? Hopefully we realize that it is, right? BD is the same length in this bottom triangle as it is in this top triangle because it's the same line. And so that is also something that I can say is equal. Okay, so looking at this, I have a lot of information. One, I can say that these two triangles are the same because I know all three sides, right? I can say that triangle ABC, ABD is congruent to triangle CDB. So make sure you go in the right order. And we can say by side, 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 right? Or I can use side, angle, side. Do you notice here I have a side, and the angle between them. So I also could use side, angle, side. So multiple options here, but either way, because this original shape was a rectangle and I split it, I'm able to show that the two pieces of earrings are the same. Okay, let's try one more of those together. So let's look at this one. Again, it says given that AB and CD are parallel, so I have the arrows, and AB and CD are congruent, how can I show that B and D are congruent? So again, I'm going to draw these two triangles separately. I'm going to separate them just like that. Sometimes I think that's easier. If you don't think it's easier, I mean, do what you want, but sometimes I think it's kind of nice to see that. Okay, I know that DC and AB are the same. I don't know anything about AD or BC. I do know that AC is the same because, right, it's the same line in both triangles. Okay, and then I also have this information that AB and DC or CD are parallel. So if they're parallel by alternate interior angles, I can say that this angle and this angle are equal, right? Is that okay, right? Alternate interior angles. I also can say that this one and this one are equal, but I only really need one. So I'm just going to use that one, the one I already have. Okay, and right now what I have is a side, an angle, and a side, right? I know two sides and the angle between them. So I have enough to say that these two triangles are congruent. So I can say that triangle ABC, and if I use the order of ABC, I have to be very careful in the order that I use on this one. So A is the angle I know. So in this triangle, that would be C. Then I go along the line with one tick mark. So that would be C to D. And then back to A. Right, so ABC is congruent to CDA by side, angle, side. So since I know that these two triangles are congruent, every piece of this triangle is congruent, right? So A and C are congruent. B and D are congruent. AD to BC are congruent, right? Every single corresponding piece of this triangle is congruent since the triangles are congruent. So I'm trying to prove that angle B is congruent to angle D. And is that true? Yes, right? Angle B is congruent to angle D by, and this is where our CPCTC comes in, right? Corresponding parts of congruent triangles are congruent. So I was able to prove that these triangles were congruent. Therefore, I was able to show that angle B and angle D are also congruent. So hopefully that makes sense. Let me know if it doesn't. Make sure you reach out if you need help, things like that. We're going to kind of take a step back and just look at side, angle, side, and side, 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 and see if we can just recognize it, okay? So let's clear this and go down. Example 3, I want you guys to try on your own. So example 3 says, which of the following pairs are congruent by side, angle, side, or side, side, side? So I want you to go through and just write side, angle, side, 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 or neither, right? If it's not one of those two, it could be neither. So go ahead, pause the video, give it a shot, and then when you're ready, hit play and let's check your work. Okay, so let's check your work here. The first one, I know 3 sides on the first triangle and 3 sides on the second triangle, so this one is congruent by side, side, side congruency. Okay, for B, I know 2 sides and the angle between them. And on this triangle, similarly, I know 2 sides and the angle between them. So this one will be side, angle, side. On D, I know 2 sides, but this angle is not between the 2 sides, right? I would have to know this angle right here in order to be able to say that these are congruent. And so these guys, this is neither. And I want to point out here, if I were to actually read this in order, right, I would have side, side, angle. So side, side, angle doesn't work, right? Or if you go left to right, it's angle, side, side, which is ass. Ha, 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 ha. Okay, real funny, right? So we always say you don't make an ass out of yourself because it's never going to work. Okay, anytime you have side, side, angle or angle, side, side, you cannot prove that the triangles are congruent without more information. So this one's neither, but more importantly, it's a condition that doesn't work no matter what. Okay. And then over here, I have 2 sides and the angle between them, and then 2 sides and the angle between them. So D should be side, angle, side. Okay, so hopefully we feel good about that. Being able to recognize whether or not something is congruent by side, 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 or side, angle, side. Let's look at a couple more examples. We're almost done. A couple more examples here. Part B says, what additional information is needed to show that these 2 triangles are congruent by side, angle, side? Okay, so if I wanted to prove side, angle, side, what would I need to know, right? What other piece of information would I need to know? Well, and there's more than one answer, right? For some of these, I guess I should say. Here I have a side and an angle, and I need to know the side on the other side of the angle. So if I know the AC, right, now I have side, angle, side. So 2 sides and the angle between them. Similarly, I'd have to know FD, right? If I know that AC and FD are the same, then I know side, angle, side. So if I could show that AC is congruent to FD, then I could say that these 2 triangles are congruent by side, angle, side. If I wanted to show that they were congruent by side, 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 I'd have to know all 3 sides, right? So I would also have to know that AC is congruent to FD, so I'd have to know it for that one too. But I'd also have to show that BC and EF are congruent as well. So BC would also have to be congruent to EF. Okay, because I'd have to know all 3 sides. Okay. All right, you guys have a try it problem now. So right here, I want you to try this. First question is STU, triangle STU, congruent to triangle XYZ? Explain. So make sure that you explain why or why not. And then B says, is any additional information needed to show that these 2 triangles are congruent by side, angle, side? Explain. So again, explain it. So go ahead, try this, and then when you're ready, we'll go over it. It'll be nice and fun. Okay, but go ahead and hit play, and then I'll see you in a second. All right, so let's look here. Triangle STU, I have 2 sides and an angle between it. And triangle XYZ, I also have 2 sides and the angle between it. So these are congruent. So I can say triangle STU is congruent to triangle XYZ. And then I can say by side angle side, and that is enough explanation. Okay, that's enough explanation to prove that they're congruent. And then for part B, there's actually multiple answers here. It says, is any additional information needed to show that these two triangles are congruent by side angle side? So yes, right? Because right now I have side angle, which doesn't work, or right angle side, you don't make an ass out of yourself. So we need more information. And I want to prove side angle side. So here's the side angle. So if I knew that ED, and HG were congruent, then I would have side angle side, right? Ignoring this side. I'd have side angle side. So we would need to know that ED is congruent to HG. So that's one option. Okay. Or another option is, what if I knew angle F? Right now I have the angle between the two sides, and angle J, the angle between two sides. Or we need to know that angle F is congruent to angle J. Either one of those things would give us side angle side. Okay, it doesn't have to be both. Just one would be fine. So whichever one you did, that's fine. Or if you want to write down both of them, that's fine too. Okay, one more, try it. Let's look. So it says, can the two triangles be proven congruent? How? And then for part B2, can the two triangles be proven congruent? How? So I want you to go ahead and try these. Keeping in mind we're not adding additional information. So just with the information you're given on the screen, can we find the triangles congruent? How? Okay, go ahead and pause the video, and then when you're ready, hit play. Okay, so let's look here. Hopefully for part A, we saw that I have two sides and the angle between them, right? So yes, by side angle side, these two triangles can be proven congruent. And really it should be like that, but that's okay. Right, we should be using the congruency. And then part B says, can the two triangles be proven congruent? How? Well, I have angle side and angle side, and angle side doesn't work unless I have more information. But I don't have more information here. So we can just say not with the given information. If I had more information, maybe I could show that they were congruent, but with just angle side, that's not enough information for me to show that they're congruent. Okay, so that's actually it for 4-3. Next lesson, 4-4, we're going to look at two more congruency conditions. We're going to look at angle side angle and angle side. And so it'll be very, very similar. If you have any questions on these two, though, make sure that you reach out to one of your teachers, and we'll see you soon.